Okay, so we are going to graph rational functions today. This is 8.10. So take a second to write down this first example, which is that we are going to graph f of x equals x squared minus 2x minus 15 over x squared minus 9. We're going to use all of the skills we learned from 8.01 to 8.09 to help us graph our function. So here's our evaluation steps, and our first evaluation step for when we're graphing is to identify all the key features. So I'm just going to create a little space to write out all my key features. So I know from what I did in 8.06 that I have x and y-intercepts. So I have x-intercept, y-intercept, and then from 8.07 I know that I have vertical asymptote. I know that I have holes. And then from right before break, we did horizontal asymptotes. So I'm just going to create this little box. So I have all my key features in one space that I can refer back to later when I'm going to officially graph my function. So I'm going to identify all of these key features. And the first key features I want to identify is going to be my horizontal asymptote, because that is the feature that we identify before we simplify this function. So it comes from when the numerator and denominator are in standard form. So I'm going to do the horizontal asymptote first. So to identify the horizontal asymptote, I look at the leading term in the numerator and the leading term in the denominator. So I can see that this is my leading term in the numerator, and this is my leading term in the denominator. So now I compare the degree of those leading terms. So the degree here is 2, and here is 2, and when the degrees are equal, we know that we take the ratio of the leading coefficients. So I'm going to do 1 divided by 1, which will give me a horizontal asymptote of y equals 1. So now that I found the horizontal asymptote, I'm going to simplify this function so I can find my other key features. So I'm going to have f of x equals, and I'm going to factor the numerator as x minus 5 and x plus 3 over x plus 3, x minus 3. As I'm simplifying, I can see that I can cross out x plus 3 and x plus 3, which means that that is where my hole is located. So now I'm going to identify my hole next. So that's my second identification, is my hole. So to find my hole, I'm going to take that x plus 3 that was in the numerator and denominator, and I'm going to set it equal to 0. So this is for my hole. So I'm going to get x equals negative 3. So I know that the x-coordinate of my hole is negative 3. To find the y-coordinate, we plug negative 3 into the simplified function, and we solve for it. We simplify. So I'm going to have f of negative 3 equals, I'm only going to use what's left, negative 3 minus 5 over negative 3 minus 3, which is negative 8 over negative 6, which is 4 over 3. So my y-coordinate is 4 over 3. So now I found my hole, so next I'm going to take my simplified function, which is f of x equals x minus 5 over x minus 3. And I'm going to find my x and y-intercept. So for the x-intercept, y is going to be equal to 0. For the y-intercept, x is going to be equal to 0. So this is my third and my fourth. So x and y-intercept. So I'm just going to substitute 0 for y, so 0 equals. And for the x-intercept, we take the unique factor in the numerator. So I see x minus 5 is unique to the numerator because it's not in the denominator, so x minus 5. And then I get x equals 5. So I know my x-intercept is 5, 0, and I'm going to write that over here. And for the y-intercept, we're going to take 0 and plug it in for x everywhere we see in our simplified function. So 0 minus 5 over 0 minus 3. So f of 0 equals 0 minus 5 over 0 minus 3, which will simplify to 5 over 3. So that leaves me with 0, 5 over 3. And finally, for the vertical asymptote, so like the x-intercept, the vertical asymptote is going to use a unique factor, but for the x-intercept, it's the unique factor in the numerator, which was x minus 5. For the vertical asymptote, it's the unique factor in the denominator, which is x minus 3. So we're going to take x minus 3, set it equal to 0, and we're going to get x equals 3. So our vertical asymptote is x equals 3 It's the whole equation of x equals 3. It's that vertical line. So now that I've identified all of my key features, I found my vertical asymptote. That's my last key feature. My second step is going to be to graph it. So I'm going to draw my x and my y axis. So I'm going to have a y axis. And I'm going to have my x axis. Now I'm going to have to scale my x and my y axis. So for my x axis, I'm going to look at my x coordinates. So 5, 0, -3, and x equals 3 from my vertical asymptote. So I could think the easiest scale for my x axis is just going to be going up by ones. So it'll be 1, 2, 4, 5, and then same in the other direction. For my y-axis, I'm going to look at my y-coordinates in my key features. So 0, 5/3, 4/3, and 1. Because I have thirds, I'm going to create a scale for my y-axis by thirds. And this will actually work out really well for me because I know that this would be 1/3. So this would be 2/3. This would be 3/3, which is the same as 1. So 3/3, and then we have 4/3, 5/3, 6/3, which is 2. And we're going to do the same thing in the other direction. So -1/3, -2/3, -3/3, which is -1, -4/3, -5/3, -6/3, which is -2. I could keep going, but there's no point because I can see here that the highest y value that I have is 1. So I'm just going to stop at 2, or the highest y value I have is 5/3. So I'm going to stop at 2 because that's 1 above where my highest y value is that I'm graphing. So now that I have my x and my y axis scaled, I'm going to start graphing my key features. And I always want to start with my asymptotes for my key features when I'm graphing. So I want to graph my vertical and horizontal asymptotes, and I'm going to use a dashed line because they're not actually there, but we're going to create this visual of them. So x equals 3. I'm going to label it as x equals 3. And then y equals 1. So now that I've graphed my vertical and horizontal asymptotes, I'm going to graph my x and y intercepts. My x-intercept was 5, 0, so I'm going to go to 5, 0, and I'm going to put a closed circle at 5, 0, and I'm going to label it. For my y-intercept, it's 0, 5/3, so I'm going to go to my y-axis to 5/3, 0, 5/3. So my x and my y-intercepts. Now I'm going to graph my whole. So to graph my whole, I'm going to go to -3, 4/3, so -3, 4/3. So that's this point right here. And I'm just going to do a really small open circle because it's a whole. So it's not actually included in our function. So I'm going to make that whole. So now I actually need to make the shape of my function. And the function is going to be created based on the asymptote. So the asymptotes are really important because they're going to help us create the shape of our function. So it's really easy for this part of our function because I can just sort of connect my whole to my intercept by using this like nice curve. And now from my intercept to my asymptote, but I'm not going to just draw a straight line. I'm going to sort of curve it to approach. It's going to approach the asymptote. So I'm going to curve it up and it's going to go parallel to the asymptote. So it's going to get really close and it's going to keep increasing to the asymptote. Then I'm going to do the same thing. So I'm going to go from the whole and I'm going to approach my horizontal asymptote. So it gets really, really close to, so it like sort of decreases towards it. But if you notice, I don't actually go through it. I just get really, really close and come parallel to it. So I have that parallel up to the point, up, and then really close and parallel to the vertical asymptote. The second one's a little bit more difficult to create because we only have 1 point, but we're going to have the same concept. So I'm going to go from this point, and I'm going to approach and sort of curve towards the asymptote. And I'm going to go parallel to it, so flatten out. I don't actually want to cross over that asymptote. Same thing over here. I'm going to go up, increase towards the asymptote, and like parallel to it. So I'm going to have that same type of curvature here. So now that I have this general shape, and it's not going to look exactly perfect, but I have the general shape of what this function will look like. So it's going to flatten out here and come up and curve, and it's going to be flat here and then come up and then flatten out and curve in the curve again. So now that I have my function, I can start identifying my domain and range of my function, which is super, super important. Domain and range. So we know that domain is possible x and range is possible y. And when we look at this function, we can clearly see that there's breaks in our domain and range. So I can see that for my domain, we have x goes from negative infinity, because there's no restriction over here. So we can see that we start from negative infinity. And then we go and we approach -3. But this point at -3 is a whole, so it cannot be included in our domain, so we're going to put a parenthesis. And then we go from -3 to 3. But because we have the asymptote here at x equals 3, we're going to do another parenthesis. And then we have one more chunk here, and the last chunk is going to go from 3 to infinity. And because it's an asymptote, we're going to use a parenthesis and not a bracket. So we know that this whole cannot be included because there's not actually a point here. And then our asymptote cannot be included, so we need to make sure that we use the parentheses to exclude those. So my domain is from negative infinity to -3, so that's from negative infinity to -3, from -3 to 3, and then from 3 to infinity. For my range, I'm going to go up and down. So I'm going to start down. So I can see that there's no restriction going down on this function. So I know that I'm going to use a parenthesis, and I'm going to go from negative infinity. So negative infinity is down here, and I'm going to go all the way up from negative infinity to 1. Because 1 is where I sort of have a cap on my function. So 1, but 1 is not included because it is an asymptote. So I'm going to use a parenthesis, and then I can pick back up at 1 because this function goes from 1. But because of this whole, I'm going to have to stop at 4/3. So it's going to be union 1 to 4/3. And I'm going to close it off there because I cannot include this 4/3 in my y values because it's not actually part of my function. Then I'm going to union that with 4/3. And if I follow this function up from 4/3 and I go up, I can see that there's no restriction. So I'm going to go from 4/3 to infinity. And then that is my range and my domain of my function. So I need to make sure I don't include the whole in my domain and range because it's not actually part of my function, and that I use my parentheses to show that it's not being included. And that is how I graph my rational function.